Alright, so we got our game here, Super Tux, and we have our cheat table that we created, and now we're going to make a cheat trainer with Memory.dll. I'm going to be using Visual Studio 2019. I'm going to create a new project. You can create whatever you want to, but I'm going to create a Windows form in C#. You can use WPF if you want to. You don't necessarily have to use WinForm. I'm going to call the project Super Tux Trainer. Here's our form for creating our trainer. I'm going to right click up here, and we're going to add a new item. I'm going to add an application manifest file. We're going to go right here where it says requested execution level and change as invoker to require administrator. Going to save that and close it. In here in the form, we're going to right click here and click view code for our main form here. Alright, so here we're going to add Memory.dll, and how we do that is we can either grab it from the GitHub page here and we can compile the source code ourselves, or we can add it from nuget, and from VS we're going to right click on the project, press manage nuget packages. We're going to go over to the browse tab. We're going to type in memory.dll, hit enter. First one here by New Age Software LLC. Going to install the latest version. Press OK. And now memory.dll has been downloaded and added to our project. Up here in the using statements, we're going to go ahead and add using memory. We go here, right inside of our class section here, above the form initializing component function here. We're going to say public mem. I'm going to actually just use the letter M here to declare it. And we're going to say equals new mem. So anytime we use the prefix m, you can call it really whatever you want. You can call it memlib if you want to, as the example states in the wiki. You can just use m to prefix it. So one of the first things that you'll have to know about a trainer is it's going to have to open the process prior to reading or writing, and we're going to have to know if that process is 64-bit or 32-bit. In this case, we are using a 32-bit game. They do have a 64-bit version of this game, but we are going to be creating this trainer for the 32-bit version. First thing I'm going to do is change our form1.cs to main form, and it'll rename all our classes and everything. So now it becomes main form. It's not a big deal. I'm just doing this for purely aesthetics. Then we're going to go ahead and create a background worker. And what we have to do is sort of loop to look for when the process is actually open. And we can do this through a separate thread, or we can do this through a background worker, but you do not want to put this sort of stuff in a timer or in the main functions, because it will be messing with the same thread that the user interface is on, which will lock up the trainer while it's searching for the game. So we're going to create a background worker here, and we can rename it. Let's call it BG worker. If we double click on it down here, that's in the do work section. This is all the work that we're going to be doing. We can do a while true, which would become an infinite loop. So this loop here will never end. And what we can do is do a system threading thread sleep 1000. And this will prevent us from using up too much of the computer's CPU processing power. And why don't we put that in the, over here, if we click on the main form, over here on the right side under the properties, there's a little lightning bolt here. It's for events. If we click on it, you can see all the events that this form has here, and one of them being when the form is shown. So right here where it says shown, if we go into this box over here and we double click, it'll create the function for us. And here we're going to start up the BG worker. So we'll just say BG worker dot run worker async, and that starts our do work up here. So here in the infinite loop, we're going to be looking for that process. So let's go down here and right click, and we're going to open up Task Manager. And Task Manager here is supertux.exe. Sometimes they're not called by their executable name. Sometimes it'll be something like this, or like this, where it's just the title. So what we would want to do then is right click and say go to details. Once we go to details here, we can see the real name of the executable. It's supertux2.exe. So what we're going to do is go over here. We have to check, is that process available? Luckily, the function OpenProcess that I've created will not only check if the process is available, but it will also open it if it is available. So we'll put if m OpenProcess which here we can see it's a Boolean, and we can either provide it an integer with the process ID number, or we can provide the process name. Let's provide the process name supertux2. You can remove the exe, you can add the exe, I prefer not to add it. So, and then we'll put the if we put an exclamation point in front, that's the same thing as saying so. Exclamation point means if it's not true. So if the process is not open successfully, then we're going to go ahead and continue and not do the rest of our code. While we're doing that, we may as well put the slow down there too as well. Oh, oops. And while we're at it, we may as well add sleep. And what I'm going to do is I'm actually going to remove the beginning part. If we put our cursor over thread, go down to show potential fixes, we can see that we can add up here system.threading, and that's what it did for us. So we have thread.sleep 1000 milliseconds, so that's sleep for a second, and down here we'll sleep for a second. And so here it's going to check if that process is available. Now what we're going to do is, because we can't necessarily modify the user elements from a separate thread, I want to create a label here that says if the process is open. Okay, so I created a label, and that text is going to say process. It's going to go up here. I'm going to create another one. It's going to go right up here. And we're going to say n/a. It's not applicable. Process is not found. Okay, we're going to create a name for this label down here, and we're going to call it proc open label. All right. Now we're going to use that name. Now we're going to use that down here, and what we're going to do is on this background worker, we have a work reports progress here. So we're going to say, yeah, we want to know the progress of that report, of the background worker. We're going to go down here and create a new function for progress changed. We're going to go up here, and we're going to create a new Boolean, proc open equals false. By default, we are if you're not familiar with programming, what I did right here is I created a variable that is going to be a Boolean, and by default, when it's initialized, it is false. Okay, and also another thing we're going to add to the BG worker is that it has completed. Once it's completed, we want it to run the work async again. We're also going to add the report progress function. All right, so it found the process and it changed the label to true. We can make it really say anything that we want to. We don't necessarily have to say that it was found. What we can do is say if proc open, so if the Boolean found that the process was open, then we can say process found. No, we could say one. We could say game found. So notice how there was no hiccup when I moved the window around. There was no slowdown. It's very smooth. And that's because everything's running in separate threads. Okay, so now we have the process open and we reported on it. So what we can do is also store our OpenProcess Boolean return value into the OpenProc variable and check if it's true or false. And then if it is, we're going to continue to the section here. We can also rename this form from form1 to super tux trainer. Okay. You can also remove the icon. I'm just not going to do an icon for this, so scroll down to show icon and say false. So here we have several 4-byte values. We also have a few float values, and we also have some scripts here. It's not really doing too much. We're just changing some of the instructions around here. Like for example, the infinite jumping, we're just changing the 1 byte to a 0. And here we're just noping out sections of instructions there and noping out several more here. So here in the address we have a pointer right here, which would be here. This is our pointer. This is our first offset, second offset, third offset. This is for all coin value, 850. Up here in the game window, you can see it says 850. Right now we can go ahead and change that value, so let's go ahead and grab it. Copy the first pointer. I'm going to go over to here, our trainer. And right here, we're going to say if the process is open, I'm going to go ahead and write memory. I'm going to do the code. Now instead of this executable, that's base. So we're just going to do base plus that, comma. And we're going to do A8, 18, A8, 18, and the last one, which was 0. 18, 0. All right, do comma. Says the next argument here is going to be what type it is. And we can see down here the types it takes is byte, 2-byte, bytes, so that'd be like a byte array, float, int, string, double, or long. And this is a 4-byte, which would be an int. That's an integer. And what I want to change, what do I want to write there? Say that many 9s. Okay, save. Start up our trainer. Process was found. Up here, we have 9999 gold. Over here, in Cheat Engine, it's reading the exact same value that we wrote to it. So there we go. We wrote our first value. Now let's say we want it to be an option. We don't necessarily always want to write that quantity. Let's go ahead and say that the user can go ahead and specify however much they want to. So let's do a text box, if I can find it. All right, we got a text box there. We're going to create another label. I'm just going to copy and paste that one, put it here. We're going to rename process to coins. And this is kind of, I call it all coins. It's basically all the coins that the character has collected over time. I'm going to change our the name of this text box from text box 1 to all coins text box. And events, here we can either do, I could do a button. So if we pull in a button and put it there, say like over here, save, or yeah, we'll say save. Or we can write send, because we're going to be sending the value. And this was just called button 1, so let's rename it to send coin value. If we double click on it, it creates the click event. Here we're going to take our write memory function, take it out, put it over here, save. So, but we want, instead of 999, we're going to say it's going to be the all coins text box dot text. So whatever the text is in here, it's going to write it. But we should probably do a conditional check to make sure that they're not writing some sort of gibberish letters or something. So we'll say if the all coins text box dot text, we're going to say if the all coins text box text is not basically nothing. All right, so if we start now, we can check out our game here, and in our trainer, if I put 9 coins, we have 9 coins. If I say we have that many coins, it can't go above 9,999, but I can basically write whatever I want to there. All right, so we'll move along to the next item. For the character state, we're going to do a checkbox on this one. And we're going to label this one. I'm going to call it Tux Always Fire. And in the text, we're going to say Tux always has firepower. Okay, so for this checkbox, under the events, under the miscellaneous section, where it says the checked changed, we're going to double click. So basically when the checkbox is clicked on, the check is either enabled or disabled, one or the other. This event is going to fire. So what we're going to do then is check Tux always fired if it's been checked. We're going to do conditional statement. If it's checked, then we're going to write some instructions here. and I want this to be an integer of 2, because 2 here, 0 is small, 1 is big, 2 is for fire. And the address is pretty much the same, except the last offset is 4. Save, gonna run. So there's Tux, and he's in his smaller form. So if I go over here and I say Tux always has firepower, Tux is now in his usual fire form, except he doesn't have any fireballs. So what we're gonna do is we're also gonna have to write the ammo here too. It's specific to this game. It's not gonna be everyone's use case. It has an offset of 8, and this is ammo. I want to do actually 99 on it. So I'm gonna change the 4 to an 8, and I'm gonna change the 2 to a 99. We're gonna stop the process, rerun it, and when I check it, now he has 99 firepower. We're gonna continue, and the 99 in this game just means that he can fire 99 at one time. It's not real ammo. We weren't an infinite amount of times. So now let's move on to like what an infinite. This right here where it says active, which is basically going to freeze the value. What it's actually doing is it's just continuously writing it. We're gonna go down to here under the level timer for read write. I can set it to 0, and I can go back in game here. And then, but notice that it's still going up. So if I press active and I do 0 and I go back into game, it's now pretty much stuck at 0 for the most point. It's at least trying to stay there. So to do that, we're going to use our BG worker up here. So our BG worker, we're going to same thing. We're going to do a write. This one doesn't have as many offsets to it. Let's be a little bit easier. Go up here. So after our condition, after our check for the process to be open, right here, we're going to do our infinite write. And so we have our base there first, and then we got this portion. I'm gonna go. I keep forgetting to stop the process. There we go. It's just a C, and that's it. And then we're gonna write integer 0. We're gonna try to keep our time at 0. But what we're gonna have to do is, actually I can't put it there now that I think of it. We have to do another checkbox because I want it to be an option. We're gonna say over here, level time never increases. Now on this one, we're not going to do that event. We will have to change the name. Level timer freeze. Level timer freeze. We're not going to create that changed event because we're not going to fire on that event. So what we're going to do is go back over here, and we're going to take this section here. I can't, inside this do work, we can't do any sort of user interface check. For example, did we check the checkbox there? So what we have to do is go down here where the progress is changed again, and we have to say if the level timer freeze dot checked, which is a Boolean, so all we have to do is that. So if it's checked, we're going to write this. Save, run, check that, go back over here, and we're gonna open up the game, continue. And for the most part, you can see that this timer value is staying very low. And that's just how often that we're writing to it. We could increase that time. Let's say that's a little too slow for us. It's running slower simply because I have these thread sleeps here. So if we were to stop it and remove, that's 100 milliseconds, which is a lot faster. And if we run that and we say level timer never increases, and then we go back to our game, see that the decimal place has moved quite a bit because it's writing that much faster. Now keep in mind that will increase the percentage of the trainer here. The CPU usage will go up the more you reduce that, the faster you have that loop going. So we'll go back to our game, our trainer. So that's how we would do an infinite loop with a conditional check if that checkbox is checked. And also we can have these checked by default. You know, I'd really prefer it. So these coins here, I'm going to go ahead and put in the text box 999. And under tux always has firepower, I'm going to say that is checked by default. So we're going to go down to the checked, set to true over here, checked, true, save. So those are checked by default. And as a matter of fact, I should probably check to make sure that the tux always has firepower is going. Yep. So now because we did that, we said that the checkbox is checked by default. That's going to be a problem for the event then. So what we're going to do is we're going to take it out of that section and we're going to put it into the progress changed. And we can remove that function. Now, what you never want to do is just go ahead and delete the function without removing it from the object first. So checked changed. So tux always has firepower. You're going to want to go over to here and select all, delete. Okay, so completely remove it. And then you'll notice that it has been removed here as well. Because if you delete it here and you don't delete it over here, when you go back to here, you're going to get some errors. So be sure to do it that way. Okay, so now I'll show you how to do this script. We're just changing one byte value is really what we're doing here. Same, as you can see, it's the same address. The only thing we changed was this last byte right here. So we're going to go to this address in memory view. Pop open memory view. And we're going to go to the address. Down here in the hex view. All right. And without having to play the game or anything, we're just going to check this. Do you see the byte that's changing there? It's right here. It's changing from 1 to 0. So what we're going to do is we're going to grab that address. And knowing that, we're going to also create another checkbox. I'm going to call that infinite jump box. Call it infinite jump. Or just change the label to infinite jump. Then we're going to go over to here and we're going to say if jump box, infinite jump box, dot checked. Then we're going to do a write memory. Oh my god. Okay, go back. And then here we're going to, here, we're going to change base to that, but we have to change the 0 to a C, because, or 6. So it's, here's F70, here's F76. So F76, we're just changing 1 byte, so it's just a byte, and we're changing it to 1. And that's it. Save, run, infinite jump. If we go over to here, we can see that the byte value has changed to a 1. And now if we go over to here, continue, now Tux has infinite jumping. Alright, for the next part we're going to do sort of a God mode, which is going to be these 2 last scripts here, which you do not lose power-ups when you get hit, and when you're small on your last damage and you get hit, nothing happens. Which is just, we're just noping out sections of memory. So we're going to do basically the same sort of thing here, where we're going to grab the addresses, go to memory, go to the address. Here's the standard instructions. Oh, we should also say that when this isn't checked, we should probably restore the 1 to a 0 as well. So if it's checked, write that, else write 0. That way we can restore it back to where it was. All right, next. We're going to check do not lose power-ups when you get hit. We can see that these bytes are changing from 8974 to 909090. So go ahead and grab that address. Jump back over here. Let's create our checkbox. Checkbox is name, God mode box, and the text label will be God mode. And we'll have that checked by default. Here, change this to base. You can actually use the name of the executable if you want to, just don't use quotes. So if I were to do that, it would still work. With the there are no offsets to this. And what we're going to be doing is we're going to be writing bytes, and those bytes are 9090. And else if not checked. I mean, we could do that, or you can just say else, because it's basically the same thing, if it's checked or not. And if it's not checked, then we have to do 897004. So 897004. Okay, and we also need to grab these two. Go to address. That is several bytes there. You can also highlight them, so let's see how far it goes up to. It goes up to E0, so let's highlight all these up to E0. You can right click and then press copy to clipboard. That copied all the bytes. So we're gonna go back up to here, write memory, whatever our address is, bytes, and put the bytes there. And the address is, and then for that we can just check it and then highlight all these, copy, actually let's put this one down here first, then go back up here. So now if we get hit by an enemy, and also you won't want to have Cheat Engine running too, because Cheat Engine will be fighting with it, because if it's not checked, it'll continuously try to write that script because I pressed disable. I had a disable section in the script, so it was trying to write the old code on top of my new code. And appears to be working. And so that's basically how you'd make a trainer with Memory.dll. And then here for game found, we can say if the process will open, otherwise the process open label dot text equals n/a to restore it back to where it was. And then you can also change the color too, if we wanted to change the color on this. Proc open label dot foreground color equals color dot, and here we can say red. And then we can do the same for above. We can say it's green. Green. And then we'll have to remove that section 2 down there about the if the process not open type stuff, because this is really the only thing our worker's really doing is checking if the process is open. But we'll go ahead and start it. And over here, game found, and then if I close the process, it says not available, not applicable. All right, and so that's pretty much it. This is our trainer. I'm going to go ahead and put this source code on GitHub on the Memory.dll section. Under Memory.dll, down in the description here, we do have a section for example code. If we click on that, I'm going to go ahead and put it under here. I have lots of other different example trainers here too. One thing we didn't go over was the AOB scanning, but if you have any other questions, check out the wiki first before. So first things that of course we had to do here was the administrative privileges, then followed by checking if it was a 64-bit game. So if it is, then we have to uncheck the prefer 32 under here, which would be under, because our game was 32-bit, we didn't have to do anything, but if it is a 64-bit game, then we do have to go under properties of the project, and we have to go under build and uncheck prefer 32-bit here. And that will allow us to run and read and modify 64-bit games because of bigger addresses. Also, if you want to create hotkeys, there's a section, there's a right up here, it's fairly simple to follow, as well as how to get started with VB.NET if you prefer Visual Basic instead of C#. However, I highly recommend switching over to C# because Visual Basic has not been getting any other features. Microsoft has said that. And the rest of the function lists here for things like reading addresses, if you want to read a memory address or write a memory address. Thanks for watching.